actually used as proxy of the transaction cost. So I'll be coming to the software exercise later. Yeah, I would appreciate just your patience, is because sometimes just switching to different files to different softwares, I might need like a couple of seconds in the transition. So I would appreciate your patience. Mofidul, I can't share my screen. It's showing that host.
Okay, just a minute, Prof. Sorry. Yes, please try again.
Yeah, now it works. So can you please confirm that you are seeing my screen?
Yeah, you can see your screen.
Okay. So yeah, just I'm going to start. So as you might see in the data set, actually I'll be playing with and then explaining all the equations and econometrics stuffs here. Just two data series. So that's the international and the domestic price of any commodity. So this is partly taken from my one of ongoing work with the Cornell University in US and then one university in Brazil. So that's basically the Cyprus data. Actually, I'm going. So this is the real world data. So I would appreciate that just I am using this data for this practice sessions and teaching, but not for the true exercise in your cases, because this is my ongoing research, and then I'm going to resubmit my revised article to one of the journals. So this is something you see that the world price and the domestic price of Cyprus. So our understanding, our objective is to see that if these two prices are co-integrated, or in other words, that if there is one price, changes in one price, if that actually is transmitting to the changes of other price. For example, like in our cases, if there is a price changes in the international market, it's actually reflecting in the changes of the domestic markets of Cyprus in Brazil. So starting with these two data set, we considered like two different steps, two different ways to test the co-integrations. First, we need to know that whether they are conjugated or just the adjustment, they don't have any co-integration or the long run relationship otherwise. But I should say, before just going in depth, this is a little bit in-depth econometrics. I don't know the participants' background. So if it does not match to the participants' background or the basics on econometrics, my apologies there. But is this something like the in-depth econometrics exercise that I'm going to show, as because like it's on the topic issue. So how to see that whether these two prices are integrated or not, this world price and the domestic prices? There are two different ways. Just considering that one price and endogenous one, in this equation you can see that the domestic price, as because this is the time series, so this is T, and then it's alpha plus beta of the world price. So this is alpha is actually, in very simple econometrics, we say that the constant or the intercept. But here, in our case, we say that it's representing the transportation, the quality difference of the commodity like Cyprus. So that's actually matching to the economic theory law of one price. So if there are the markets functioning very well, so if there is change in one market, that actually will transmit to the other market, but until certain point, as because it involves or it takes like considers the transaction cost. So its alpha is actually representing the transaction cost, which we say that the transportation and then the quality differences. And beta is the estimated long run coefficient, and then the error correction is actually mu t. So you see that one, mu t is representing the error correction term. So in this case, there are two theories. For example, like it's called the Granger representation theory. It's just normalizing one variable, in our case, the PD, and then simple running the OLS, and then saving there's mu t, that's the error, or the error correction term. The second way is considering two variables, in our case, two prices as endogenous, PD and wall price, and running the model jointly there, and then solving with the maximum likelihood estimation. But here is OLS. So in the time series equation, time series data, most of the cases, data are not stationary. So first we'll have to check that whether this PD or the wall price, they have any unit root at the level. So we'll have to use some tests. For example, in my case, just I'll show only one. That's the augmented Dickey-Fuller test. So this is actually the equation of this ADF, augmented Dickey-Fuller test. It's coming from this mu t. So it's saying that this is the level value, but here you see this is the first difference value. So this, or the change value of mu estimated mu t. And this is the estimated lag value of mu. And then this is something the estimated lag difference lag value of mu. So we do that one when we say the Enger-Gunjar approach, but in other approach is the Johansson co-integration. So I'm just giving some basic starting test before going to the real model. So I'm not going to show here the Johansson, but in this case, Johansson is not like any of the price variable. In our case, like the domestic price or the wall price, we are considering as like one endogenous and one exogenous, but both are actually considered as endogenous variable. So these are the difference. Our target is saying that this variable integrated when this level is level variable has a unit rate, but when we do the first difference, we do not have any, we do not see any unit rate problem there. Similarly for the wall price cases. So that's why you said that where the PD and WP are assumed to be integrated one, meaning that when we do the first difference of wall price and first difference of the domestic price, we see that there is no unit root problem. So data is actually stationary, or in other words, we say that follows the white noise problem. It's meaning that in econometrics, it's saying that it follows the IID. It's independent and identically distributed. And in the Enger-Gunjar theorem, so if we like do the ADF test of this residual, and then we see that they are stationary at the level, so we can conclude that these two variables are co-integrated. Is there any question? Or
yes, Prof.
would you like that I finish first and then I take questions and respond, or just step by step? How do you?
I think better to answer in the after finishing your session. That's better. Or if you can want to take the question, as already I found two questions in the chat box. Do you want to hear that question?
Okay, please. Yeah.
Okay. So one question from Brother Afu Sufyan. He said, Prof can explain more on the transportation and quality differences?
Okay. So, yeah, please.
Okay. And second question from Brother Azim. Why should we do first difference?
Okay. The first question, that the transportation and quality difference. So in the law of economic, law of one price actually saying that if there is price change in one market, And then if markets function well, the changes of price in one market will immediately transfer to the changes in the market, other markets. So in our case, like if there is a price change in the world market, that will actually get transmitted to the changes in the domestic market. But until certain point, for example, the price, when we say the price in economics, it's kind of like abstract coming from the demand and supply. So if there is a price change, I don't know that whether you will understand some special issue, just I'm going to explain. If there is any price change in big consumer market in Dhaka, for example, in Bangladesh, I know many of the participants are from Bangladesh, so you will understand. And if there is any price change in Dhaka, and if there is an excess, demand there in the Dhaka market, so the commodity from Mymensingh market will get transmitted to the or transferred to the Dhaka market, is because there is an excess demand there, and then in Mymensingh there is an excess supply, and that's why the price is low than in Mymensingh than Dhaka. So the commodity will actually move to Dhaka market until certain point, as because like price adjustment will not automatically come, as because the commodity movements requires transportation and other cost involvement. And then more with the numbers. For example, if there is a price of like any commodity 20 taka in Mymensingh market and Dhaka market is 30 taka, right? So some commodity will actually move from Mymensingh to Dhaka, but movement from Mymensingh to Dhaka needs some sort of like transportation cost and so on. So it's not that if they just move their commodity from Mymensingh to Dhaka, they will immediately get the additional margin of 10 taka, as because it requires the transportation. So in the law of one price is saying that the price will adjust, but until certain point. So it's not beyond that point that adjustment will take place. For example, like if there is what I said that the 30 taka in Dhaka markets, but if it requires like 5 taka transportation cost, so the Mymensingh producers or the commodity from Mymensingh will get transferred to Dhaka until 25 taka point. If it is less than they receive less than 25, they will not move because it requires 5 taka. So that's actually representing the transportation and the quality difference thing. The second question, that why the first difference, is because this is the time series data, and then most of the time series data actually has the unit root problem. What is the unit root problem? It's actually the data do not follow the stationarity, so it violating the rules of econometrics, and that's why you do the first difference, as because if you use the label data, that you will see that in every subsample the mean and variance are changing, and that actually violating the econometrics rules. So that's why you do the first difference, and then we make that data stationary and then do not have any unit root problem, and that's why we do the first difference of time series. And that's why we do test the ADF whether they have like the data have any unit root problem or data are stationary or not. So that's basically the answer of why we are using the first difference. But in econometrics, times in econometrics, yes, sometimes it's possible that they do the second difference, but it's very less, very exceptional in the financial market. It's possible to have the second stage difference, but most of the time series data actually required to make that the first difference, so that you do not violate the econometrics rules. So is it okay? Mofidullah is okay? Sorry if I am not correctly.
Yes, Prof, it's okay. Continue, please.
Okay. So yes, this is the price transformation. So we assume a unidirectional relationship between PD, the domestic price, and the world price. So that's the equation here. You see that the unidirectional, or that in other words in econometrics we say that we just normalize this one. So this PD is endogenous and wall price. So you actually sometimes you understand without testing, but when we use this data in research or in paper writing, we actually do all the test, whether they are determined endogenously together simultaneously, or just we can normalize. For example, if we know, for example, like in the citrus market, we analyze the wall market price, that's the New York price, and this is the price of the Brazil market, and convert it into, like, it's called the frozen concentrate juice price of orange. So if we know that it's actually that the market share of Brazil is not that big, so it's actually responding with the wall market, or sometimes it's really big, so it's like otherwise round, it's not the wall market price, but it's the Brazil or the domestic market price is actually influencing the wall market. So it's something like also from your background data or the literature can help you to identify or to assume that whether actually it's the PD influencing WP, or WP is actually influencing PD. But it's better always to do the test and then seeing that which is actually exogenous and which one is endogenous. But in our case, like for estimating the threshold, I'll be in fact using this equation. But before that, even we can see that considering two variables, endogenous and testing using the Johansson method. Anyway, so we assume a unidirectional relationship between domestic price and wall price, but it is possible that these two prices are determined simultaneously. So that's what I already said. And then, sorry, just when I will go to the software, I can explain more detail, and then you'll understand more detail how it works. But in this PowerPoint, actually bit of like different steps and the theories I'm explaining now. So we conduct weak exogeneity test to examine whether the co-integrating equation influence both prices. So it's again like considering or to understanding that whether these two prices are actually determined simultaneously. So whether we can consider these two prices endogenous and testing. Sorry. So that sort of like weak exogeneity test also can say that it's actually the wall test. An identification of the short-term dynamics needs at least one restriction on each equation. According to the Granger theorem, the existence of threshold co-integration justifies estimating threshold error correction model. Sorry. So, and then there is one theory. So I'm not going to explain the papers, but it's not these all steps or the econometrics are actually my innovations, but the different steps and then putting different equations together to get our target value. That's the threshold, and then estimating the asymmetric threshold error correction model in price transmission equations based on the estimated threshold. That's the transaction cost. So there is one paper. You can just go to the reference if you like to. It's Anders and Gangers. So we incorporate two important features of price transmission, such as existence of threshold and possible asymmetries in the long run and asymmetries in the short run. So it's meaning that I said, for example, in the error correction term, so is that adjustment or the speed of adjustment, it's actually say it's coming from the error correction term. Is there, if there is any existence of threshold, even if we identify the threshold, whether within the threshold there is the kind of like asymmetry. Just imagine you have the error correction from your OLS, and then you split into two different groups based on the estimated threshold, and then you get some values. So it could be like positive or negative, like this is the residual, right? And in that case, you split into two different way, like the positive values and negative values. I'm coming to that equations in the next slides in a minute. So it's like estimating the threshold, but also examining the threshold if there is, and then within the threshold if there is an asymmetry. I mean, when there is a positive deviation and when there is a negative deviation, how they are behaving, whether they are the same, statistically same, or they are statistically different. So it's in the long run. And then asymmetric in the short run price equation. For example, you see that one, this equation, this is the mu estimated mu t, and this is actually the mu t of lag. So this is the short run variables. So seeing that whether these are actually also related to this one, and then we actually play with this this part IT. That's the indicator function I'm coming, but I'm sorry that if it does not make clear to you, because it involves use like exercise. So I'm putting just the main equations here, not all equations, that how it derived actually. So where the autoregressive term of residual. So this is the residual, and these are actually the autoregressive or the autoregression, right? So these are the autoregressive term. So this can be separated into two regions, namely in and out. So regions depending on whether the threshold variable, this is mu t minus d. Again, you see that it's d. It's not like any number 1, 2, or 3. That exists a threshold value. That's what we say is the gamma, right? And it is inside threshold interval. Just you imagine you estimated this one, and then you sorted this value like this residuals, and then from this residuals value you identify this threshold gamma. And then for identifying the in and out regions, so this is actually the 2-region threshold model. There are some like 3-4 regions, 3 regions already in the econometrics literature, but theoretically there are 4 regions, but it's not econometrically solvable, so it's not available in the literature. I mean the estimation. So it is inside threshold interval. So we define how we define the input in and out regions. So it's here. Out regions define when the deviations are outside the threshold interval. So you imagine this is the minus gamma and then gamma, and then the outside which is beyond this interval, and then IT is an indicator function. And then how is defined the indicator function? And then in the indicator function you will actually understand the in and out kind of variable there. So this is the indicator function defined here in this equation IT. So when the absolute value of this mu t minus d is bigger or equal than the gamma, that's the threshold, we consider like 1. This is kind of like the binary variable of the dummy we create there in the data set. And then in the IT function, if this value is less than the gamma, the threshold, we put 0. So it's like you already created these variables mu t minus d, and then you just define 2 new variables that's based on this indicator function, that in and out based on this indicator function. And then how it is that? Then if it is more than the threshold, and that the big challenge that how do you estimate this threshold, I mean the gamma value, and that's the work of us, right? And then if it is less than 1. So this gamma represents a threshold by which movement toward the long run equilibrium relationship are asymmetric. And D is the delay parameter. So which actually explaining the change from one region to the other. We said that I said that it's 2-region model. So it's like one single value, it's moved from one region to other, and how many months actually, or the how long it takes to move from one region to other region. So in our case, we are using the monthly data. So that's why it's saying that how many months actually is taking. So it said that it's the delay in the change, but it's not really, it's given. Again, D is determined through statistical procedures. So we'll have to estimate D as well, right? So you see that what variable actually we'll have to estimate from here, like this gamma, and then the D is called the sometimes delay or the decay variable econometrically. But there are some conditions. For example, like this one, when we estimate row 0 and row 1, for example, like here you see that row 0 and row 1, these 2 variable, right? So these 2 variable must be less than 0. If you want to see that it's actually model converging and then the speed of adjustment is taking place. right? But that could then the rho 0 and rho 1 is actually in the two region speed of adjustment. So that must be negative, as because like when there is a long run relationship or the equilibrium relationship, in the short run they are diverging, but in some months if there is a conjugation relationship or otherwise long run relationship, they are converging towards the main equilibrium point. And that's why we said that the speed of adjustment must be the coefficient of speed of adjustment must be less than 0. That's the negative, right? And then sum of this value must be 1. So in our equation, when I will be showing you that, you will see that how it's actually less than 0 and less than like 1 value here. Here in equation 1, 3, and 4, for example, like this equation, so we started with this just simple OLS, and then this is the 3. We actually just split it for getting the threshold, and then threshold asymmetry 3, and then we define this indicator function. But here we use the mu, I mean the residuals, just the absolute of residuals, mu t minus d, and d is the delay parameter that also will be estimated statistically. We use so when we use that 1, 3, and 4 together, this is called the threshold autoregressive model. But there is a limitation in the threshold autoregressive model in the literature. So it's called, then we move to, if just solving that problem or the avoiding that limitation. So we reformulate this model as MTAR. That's called the momentum threshold autoregressive model. So in this case, we just redefine the indicator function. So instead of using this mu t, I mean the label value of mu t, but it's absolutely absolute value. But in the momentum threshold autoregressive model, we use the first difference. You see this one, the difference of this mu t. So we redefine this Heaviside indicator function as this one. So you see in the equation 5. So what is the difference between equation 4 and 5? It's only in equation 4 we use the label value, but in equation 5 we use this like the first difference. So this only the difference, and then we define this 1, 3, and 5 together as the momentum threshold autoregressive. Why is there are kind of like econometrics. I'm not going to in-depth explaining that one, that will make the equations and the whole modeling steps more complicated. So in this case, for example, just we are not assuming anything, just simple error correction model. So this is the simple error correction model, you know, that we found as two variable, PT and then WT. They are co-integrated, and that's why it's some cases it's PI, yeah, there should be like one P D and then Y and WP. So this is the error correction model. So you say that lag of this variable, lag of other variable, that's the wall price, and this is the error correction term. That's actually come from mu, from my first equation. So you see that's mu. This is the error correction term representing the deviation from the equilibrium in the previous period. So this equilibrium model, based on these indicator functions and the potential asymmetry and the threshold in the equations or in the price, this error correction model can be rewritten in threshold error correction model as this one. So you see these are same here. So PT, that could be like I is equal to PD and WP, but this is actually not endogenous. This is the exogenous variable, and that's why I didn't put here just on that P is something different, XIT. So that's the exogenous, always in the equations. In my case, like since this is the international price to domestic price, so exchange rate is one exogenous variable, and also rainfall we considered in this analysis. So P is the price vector, X is the vector of exogenous variable, and ET follows a white noise process. That's I already explained. So to identify the existence of threshold effect in the error correction model, we employ, that's something the test, T-say test. In where we estimate a method of recursive least squares to examine if the coefficient of autoregressive process of ECT are constant or linear. So it's basically based on the, in my cases, it's not the TAR, but the MTAR. I'm actually going to show you the momentum threshold autoregressive model. And we are using the F statistics to test the null of linear process. And then if we can reject the null of linear process based on the F statistics, we decide that there is an existence of threshold. So in that case, we'll have to use the threshold model. Otherwise, just the error correction model without considering the threshold. So what is saying that is MTAR is actually some sort of test that showing whether the model follows linear process or not. So if model does not follow linear process, that means the non-linearity there, and that's why you will have to use the threshold error correction model based on this MTAR F statistics. Is that okay? I'm talking too much?
Prof, it's okay.
Okay. If the participants are not, my understanding, sorry for that, to the participants, maybe it's very difficult to follow us because like so many questions. So here, once it is identified that there is existence of threshold here, if the threshold effect is autoregressive process of error correction is confirmed, the threshold gamma is estimated using a grid search approach. So the MTAR F test is actually saying that there is a threshold effect there, but we do not know the threshold value. That's the gamma value, right? So how to estimate that gamma value? So that's one approach is there. It's called the grid search approach, and then how it works, I'm going to explain it. So it's an Econometrics works published by Chan in 1993. So the threshold values are estimated through a search over all possible threshold values, minimizing the sum of square errors. For example, you are playing with the error correction term, and then in the OLS simply the error term, right? So you have all these error term or the error correction terms from your estimated equations, the OLS, the equation number 1. And then you are searching one value. That is the threshold value. And then that will use as proxy of the transaction cost in theory, right? So how are you going to estimate or identify that threshold value? So it's the value where the threshold values minimizing the sum of square error. So the estimated residual series, a possible threshold value is first sorted in ascending. For example, in my case, like I'll be estimating with the 140 observation. That means like, yeah, 13 years. So how many months actually is coming? So you have that number of residuals from your OLS, and then you just sort in ascending order all of your residuals values, right? So the largest and then the lowest 15, largest 15 and lowest 15, you are just simply eliminating. That's also, otherwise you say the truncating. This 30% of observation, the lowest 15 and then the highest 15, because we don't expect that the threshold or the transaction cost value or the number could be within that range. So that's why just we truncated that 30% of observation. So we use 70% of the values in the middle of 70% of the values as possible threshold, but we do not know exactly which one is the threshold. So the estimated threshold yielding the lowest sum of square error and is chosen as appropriate threshold. So econometrics in the software, it will show a graph that where in which point the SCC is the lowest, and that point will actually be taken as threshold value in our estimation. Then again, you found the threshold value gamma, but it's saying that when you estimate by using that grid search approach, that value in the AR process does not follow a standard distribution. So it's in the Hansen 1997 argued that the null hypothesis of linearity in the AR process that we already found from the MTOR statistics. Therefore, the conventional test is not appropriate. So we can't use that the standard distribution, and then we can't use the tabulated critical values, right, to see whether they identified the threshold value is significant or not. It's possible that you identified threshold, but it's not really significant. So we can't use actually the threshold model then. So we can't use the conventional test. And then the Hansen 1997 proposed a Chow type test for threshold values in where he used simulations method and provided p values based on bootstrap simulations. So here we'll be doing the bootstrapping of like 5,000, 10,000 values. And then we'll find the new p values. And then we can see that whether the estimated threshold gamma is significant or not. And based on that decision, we can use the threshold error correction model or just the error correction model. And then if it is like identified the threshold there, and then we see that whether that threshold actually follows any asymmetric behavior or that just the symmetric. So in that case, we'll be estimating the asymmetric threshold error correction model and then the symmetric threshold error correction model. And then we'll be based on the appropriate model based on the model selection criteria, for example, like EIC, BIC, etc. You know that EKIK information criteria or the Bayesian information criteria, or there are some like 5-6 different criteria like FPA, final prediction error, or the likelihood ratio test, etc. So we use Hansen to estimate the maximum F stat and p values using bootstrap methods. Then done, right? So I'm not going, it's already said that. Okay. So now we know that we identified the threshold. We know that whether they follow the symmetric or asymmetric behavior when they adjust to the equilibrium point. You know that the domestic price and the world prices. So all of this information actually, now I'm coming to the main equation. So this is very easy, this understanding of equation. That the difficult task is actually to conceptualize and doing the test that I already said before, the Chan, the Hansen, and then the TSE. These tests are actually a bit difficult without reading in depth that the articles of the literature. So this is the model allows to nest together the short run and long run dynamics. It's simultaneous representation of equation in threshold error correction model. So we do not consider in this equation asymmetric behavior, just we consider the threshold behavior here. And then we consider the simultaneous representation, meaning that, so it's not only the domestic price, but also world price. You see that? So it's written two price equations. So we are assuming that we do not know yet that whether DP is endogenous and WP is exogenous. But if we do know that, so in that case, okay, we can drop these equations that we are not going to estimate this one. We'll be estimating but I kept it here just to give you some flavor that how it's actually moving when we just estimate the simultaneous representation. And in that case, it's not the OLS, rather the seemingly unrelated regression through model will be estimated. So this is the term out represent the deviation from the long run equilibrium, which is larger than the absolute value of the threshold. Threshold should be its gamma, not theta, sorry, it's written differently here. It's gamma. This threshold is the transaction cost. So you see that how you can link with the law of one price. It's actually coming to my first couple of minutes discussion that how they are linked, right? And then in is actually represent the deviation from the long run equilibrium within the threshold interval So that's I already explained, within the interval and beyond that interval. And this XC is XIT are the vector of identifying variables, such as what I already said, the exchange rate, rainfall for the short-run parameters. And then we employ system of equations to examine threshold. And then if it is asymmetric, then the asymmetric, but not yet the asymmetric here, between the world price transmission to the domestic price, world price to domestic price transmission, right? So this, you see, this is completely exogenous variables. So only these two variables, the domestic price and world price, they are treated as endogenous. And that's why just in the simultaneous representation. And then if we just estimate two equation, and that if test confirm that we can't, these two price, actually the domestic price and international price influencing each other. So that's what we say that the bidirectional causality in the case of causality language. So we use these two equations and estimate, in my cases, in my analysis, we estimated the Schur model, that's the seemingly unrelated regression. And then you see that now in this 8A and 8B, it was the threshold error correction model. But here we just incorporate the potential asymmetrics in the threshold and also in the short-run dynamics. So possible short-run asymmetrics in price transmission can be examined by splitting the contemporary and lakhs of independent variables and lakhs of endogenous variable into positive and negative change. So you see this one, this is the domestic price. So these are actually that the error correction, and then this is the error correction asymmetric, and then also threshold asymmetric. But for capturing the short-run asymmetric, so we splitted this variable, like the first difference of the domestic price and then the difference of world price, but using different legs. So we split it. It's actually when we say the first difference, difference means change, right? So change means that could be the positive or that could be negative change. So our intention is that, for example, if there is a price like going up, or if there is a change, positive change, whether that positive change actually reflecting to the changes in the domestic price, that's the dependent variable, right? And also, if there is a negative change, I mean, if price goes down, that actually reflecting to the changes in the dependent variable, that's the domestic price equations. And it's possible that the changes in domestic prices also can regress based on their own lag. So it's not only the lag of exogenous, but also dependent and independent variables. And splitting into two different, like positive and negative, actually is saying that whether they follow symmetric behavior or asymmetric, meaning that whether price goes up or whether price goes down, the coefficient are same or not. I mean, the responding in the domestic market, whether they are same or not. So if they are not same, so that meaning that there is an asymmetric behavior exists, as because, like, for example, international price, when the price goes up, when there is a changes, it's not immediately or it's in the same way, it's transmitting to the domestic price when it goes down. So there are some differences, but in theory, it's like when there is a price goes up, it's not transmitting quickly, but when its price goes down, it's transmitting quickly to the domestic price or to the left-hand side or the dependent variable case. So this is the equation. Actually, in the software, I'll be showing that how these all equations, but it looks like very fuzzy, very kind of like the cloud. But if you just carefully see that it's like expanded different variables, like, for example, this is the change of the domestic price in leg 1, leg 2, but this change actually split it into two different ways, the positive change and negative change, by using the positive and negative sign. And then also in the world price cases, same, right? And then actually the exogenous variable exchange rate, that's I already tested. That's also follows the that's also integrated I1 variable, and that's why just I use that the first difference of exchange rate. But here in the rainfall I didn't, as because we didn't find any like stationarity or like I1 there. That's the I0. I mean that that data actually we can use that data, level data, in our estimation. So based on this one, this is the last slide actually, so it's taking time. Equation 9a is the asymmetric threshold error correction model for the PD, and equation 9b is the asymmetric threshold error correction model for wall price, exogenous variable, etc., etc. Equation 9a and 9b, this 9a and 9b, these equation are estimated using SURE and OLS, and AIC is used to select the model. We run simultaneously, so using the seemingly unrelated regression and then also individually simple OLS. And then we use the AIC and SBC or the BIC values to select the appropriate model. So minimization of the AIC value is actually helping you select the appropriate model. So, and then we estimate the SURE model is because it is likely that wall price and PD are determined simultaneously. And from equation 9a, we test threshold asymmetry. So if they are same, so it's not asymmetric, but if they are not same, it's asymmetric. And then also in the short-run asymmetric, you see that the coefficient from the earlier equations, 9a and 9b, if plus minus they are same, it means that they are symmetric, but if it is not same, they are asymmetric. So it's in the equation. And then for the contemporary and then the lag values of the endogenous and exogenous, we also tested this one, like summing all of the wall price, for example, plus and minus. See that we use the 3 lag, and that's why just we put 3 here. They are same, so we can conclude whether they follow symmetric or asymmetric behavior. Also the domestic price should be domestic price, not PD or DP. It's same thing. So these are all things, equations. So I guess it's really I made like, I didn't find any other way to make it in very simpler and way, but these are actually the steps in a nutshell. So how we just go, I tried to show the equations and the different tests, but you just go, this is the order of integration, and then test the causality using the vector error correction model, or just you can use the Anger-Gonzalez, just simple OLS. So just consider one variable as endogenous, and then estimate the Tr and MTAR model and see that which model is actually best fits to data. So in our case, MTAR model, I'm going to show that one. And then for identifying which one is the best TR or the MTR, we use the different lag length criteria such as AIC, BIC. And then again, it's possible to test or doing this modeling exercise in 2 different cases. Like you consider gamma, there's the threshold or that is 0, null. So very simple. And then, but just for the exercise, but if you want to do a real research and then you consider like null threshold, you will get like, there is a possibility to get the paper rejected. And then otherwise the reviewers will make many comments that why you use that one. So that's why it's better to use the estimated threshold. So in my case, like estimated threshold. So we examine possible threshold effect using that TSA and then delay parameter, that's the D value I say. And then once threshold effect is confirmed or that no linear process is actually rejected, meaning that there is non-linearity, and we use the chance approach. And then we find the threshold value. And then based on threshold value, as because it does not follow the conventional test, does not follow the standard distribution, so we do the bootstrapping, right? And then we estimate the asymmetric threshold error correction model. It's possible to do OS, the sure or the wireless, and then examine which model fits better to the data. We conduct model diagnosis test, and then it's not only the model selection criteria, but also you do the models other diagnostic tests, for example, like serial correlation, LM or the LQ test, heteroscedasticity, non-normality, stability. There are different tests, and then based on that you decide that which model actually the appropriate one, and then see that the actually estimated coefficient fits to the real world case. And then the short run and long run asymmetries are tested using F statistics from the estimated asymmetric threshold error correction model. Is that okay? Are there any questions from here, or just I go to the software playing with data and then maybe just try to link and then make your questions or drop your questions from there?
Prof, I see one question there. So this question is from Madam Rafika. She said, if variables are mixed, I0, I1, and I2, can we run TAR method, or this method require all variables similar I1 or I0?
Yes, very good question. Thank you so much. It means that you are understanding very well. In the TR, that in my cases, like we use that all variables are I1, but you can use in your final model, I mean the error correction model, this is simply the, I mean the error correction model, but different specification, I0, but that's the exogenous variable. You can't use that as endogenous. In my case, for example, you have seen that I use the rainfall, that's the I0, and the exchange rate, that's I1, but that's the completely exogenous. I didn't consider the exchange rate as endogenous variable. So only endogenous variable PD and then WP, I mean the domestic price and world price. So, and then I don't know, or I didn't see that you can use like, if it is the I0, you can straight use the simple wireless. So you do not need to go through all of these tests that's actually been used in the time series econometrics. But for the TAR methods, it requires at least the endogenous variables are I1. And then you can have like I1 and I0 in the final model. There's the error correction model. But in the TAR, threshold AutoRegressive, that's actually the testing. So I don't think it's because the threshold AutoRegressive is coming from your like the error correction term. There's the mu in our case, or sometimes it's epsilon or theta in some equations. Some literatures they're saying. So it requires I1. Any other question?
Okay, thank you, Prof. So from our participants, if you have any more questions, you can ask directly, or even you can write in the text chat box. Is there anyone?
And then I move to the software.
So, Prof, one more question in the chat box. Brother Zakaria said, what is the difference between NAR, DL, and MTAR?
What is the difference between NAR? I don't know the first nomenclature, the variable or the model NAR, $DL. I don't know. I didn't use this one, right? In my presentations, I use the MTAR.
NAR DL.
So it's did you mean the non-linear kind of like ARDL model, AutoRegressive distributed lag model?
Brother Zakaria, can
yes,
ask?
you can hear me. I'm meaning the non-linear IRDL.
Yes, non-linear.
Non-linear.
Yeah, that's the AutoRegressive distributed lag model. Yes, it's actually the there is difference, as because like in the MTAR, you are actually using the TAR or MTAR to estimate the threshold value, and then there are some other tests that what I shown to get whether that threshold value are significant or not. But nonlinear ARDL, they are something different. ARDL is completely something different than the threshold autoregressive error correction model. So we use the MTAR model to actually to estimate the error correction model. We use the MTAR test. So you can recall from my presentation, MTAR F statistics we are using just to test whether the AR actually follows the linearity or there is non-linear issue. But ARDL is not that much. And then, yeah, I can't say more as because I didn't use that much ARDL model before, but my understanding they are different. Is that okay, Jahangir?
Okay, Prof, he replied, thank you. So for the participants, maybe we can proceed for the software session as Prof wanted to do. If you still have any question, you can write in the chat box, or at the after this session, you can ask question directly. Thank you, Prof. You can proceed.
Okay. So just a second, I'm clicking my software. So do you see the screen of EBUs here?
Prof, screen share is already stopped. Can you share again?
You see?
Yeah, if his screen is appeared here.
So it's EBU's 11 student live. So actually I downloaded yesterday. So I can't save my output or the data. So I'll be using this EBU's 11 student live just for first 2 steps. I could have avoided this EBU just going straight to RERS, but maybe just for some of like those who are actually beginners of using the time series and then starting initial test, you need to, and then co-integration and exogeneity, weak exogeneity or the strong exogeneity, maybe it's better. So I'll not take much time here, but rather I'll use my time in REST software. So so you see that just you are importing as foreign file in EBUs, and then click next, and next. So finish. So you see that these are your variables, right? This is the exchange rate, Brazilian dollar to US dollar. And then the domestic price, world price, this is the rainfall, and this is the war, and this is the residual, and this is constant. So just I click on this two variable, open this 2 variable. Okay, as group, you can open this individually just to test the unit root, just to make sure that whether this variables are I1 or I0. So again, like I'm not going to explain all of this test because there are many tests for confirming whether the variables are unit root or not. So this is this one. I'm not doing the grouping. So just again. So PD unit root test. So you see that one. You could recall the equation, my second equation that I'm going to estimate here, right? But based on the PD, not the residual, it's same thing. Like that, you just derive the residual value based on your estimated OLS. PD is equal to alpha plus beta PW, and then here, but here just PD. For example, level value and then you can use this drift or the intercept or the trend and drift values or the none. So you can, how do you understand that whether you should use intercept, trend, or intercept or none? It's actually, you can, like initial stage, you can plot your data and then can see that whether data actually follows any trend. Just seeing the data graph, then you can understand whether data follow any trend or not, and based on that understanding, you can also you can use different equation and see that how it's actually sensitive to the significant level. So here in the level, I use this level and the intercept, and then I put at it is here just automatic selection is software, like how many lakhs actually the software really use. So maximum lakhs 13, that's actually the monthly data, so it's 12 plus 1, right? And then this is the SIC or the SBC criteria we are using. So here you see that one. So it's simple, just test. So what is the hypothesis is that PD has a unit truth. So it's non-stationary, violating the econometrics, classical econometrics rules. I mean, it does not follow like the constant mean at the constant variables or the IID. So that's why just we can't use this level variable. So you see that PD has a unit truth and it's accepted, right? So meaning that it's not it's not I0, right? And the same thing, like here I use like constant or the intercept, you see that, or sometimes we say the drift. If we do that one, even you see that this C is not significant here. And then we also can check this one. Now the trend is, right, but C is not. So still, like, irrespective of any equation or any case, whether you use the drift or the trend value, you see that the PD has a unit rate, meaning that the PD is not I0 variable. Then what we do that, like first difference, and then in the first difference, as we didn't find the intercept in either cases significant in the level value, so we are not using any intercept or trend. That's simply just the none, because it's already we are using the first difference to check whether it's I0 or I01 or I2. So we see that it's like significant, right? So DP has a unit truth, it's rejected, meaning that DP does not have any unit truth problem. So we can conclude that the PD, domestic price, is I1, right? So it's indicated 1, meaning that that when we do the first difference of the domestic price does not have any unit truth problem. So follow, that's the stationary, right? Similarly, we do this test. There are a couple of tests, but I'm not going to spend everything. Like you see that this is the augmented Fuller, and then how many? Like Fuller test, Philip Perron. I think the other colleagues, other trainers, those who will actually teach or the present the time series analysis, they will also start with this test. So that will also give some understanding in the next couple of days, those who will actually participate in all sessions. But there are some other tests, like, you know. So what I did, or you will do that, like you use couple of tests, and then see the conclusion, compare the conclusions. So if they are different, and then you do all the tests and then see how it's sensitive. But for example, you use the augmented Fuller and then Fuller GLS or the Philip Perron, and then you see the same conclusion. So you do not need to do all these things. But those who are actually even doing the modeling exercise in time series data, even in the ADF test, using the nonlinearity and so on, there are a couple of, or the breakpoint, for example, there are a couple of other tests being used by researcher. So you see this one, and then standard unit truth test done. And then I do that for the wall price. And do the label put here, and you see that not significant. And then use the first difference and then see it's significant. So we can conclude that this domestic price and wall price, they are I1 variable, integrated one. So there is a chance, since they are integrated, there is a chance to have that co-integration relationship. So either we can use this simple OLS, like for example, this group, and then estimate equation, for example, like that least square, you do that the PD, PW, and then you run, you save the residual, play with these residuals. But the second steps I explained, just considering two variables simultaneously, they are endogenous. So we can't use this, and that's called the Granger representation theorem. But that's the Johansson approach actually being used when we consider, or when researchers consider two variables endogenous, meaning that you are not sure that which one is actually influencing. Maybe it's possible that two variables are influencing each other. So what we do that in that case, so now we open this two variables as simple bar. This is called the vector AutoRegressive. It's not the restricted but unrestricted bar model. And then see just okay, as it is, you put here, and this is the simple bar. Okay. And then how many legs or the optimum leg you should use? You'll have to check with some, like the leg structure, for example, leg length criteria here, as it is 12. So you can see that there are different, like the test, log likelihood ratio, final prediction error, EIC, SC, Hanan Queen. There are different like test, and then it's 0. What is the value? It's 1 leg, 2 leg until 12 leg, because I already put the 12 value. So it's showing that, for example, it does not show, meaning that maybe there should have like some more legs, but based on LR, it's showing that optimal leg is 7. Based on FP, it's showing that optimal leg 2. Based on AIC, it's showing optimum 2. Based on SIC, is showing optimum 2. And then based on HQ, is showing the optimum 2. So you see that this 4 actually showing that the optimum leg size is 2. So we can decide that actually we can use the 2 leg here, right? And then also there are some other tests just to confirm. Leg exclusion test. For example, you see that leg 2 you cannot exclude as because it's joint test is significant here. So you can't reduce leg number like from 2 to 1. So we are using leg 2 here, right? And there are some other things like based on how many legs you can do the autoregressive roots of the polynomial graphs or tables and so on. So you see that when there is optimum leg identified, this value will stay inside this circle, even not on the circle. So you see that all of these 4 values. And why 4 value? Because in our cases, 2 variable and 2 legs. So there are 4. So 4 dot here, right? So it's inside this circle. I'm not going to detail everything. So here now we move to, that's the bar. But as we found that PD and WP, they are I1 variables. So we should check whether they are conjugated or not. So that actually giving some impression that how many legs you are using. And then when you use the bar, but when you use the conjugation test, meaning that bar is there, but the restricted bar. So there is one co-integration, as because we have like 2 variables, PD and PW or WP. So we can't have more than 1 co-integration relationship. So there should be 1 R. So that actually will come from this test. So you see that in our cases, because we already confirmed that, okay, we can use 2 legs, that's the optimal leg here. And there are a couple of different models, like based on that, whether you want to use the intercept or trend with the co-integration equation and then the test bar equation, because in the bar there is no co-integration relationship, but when you estimate the restricted bar, that's the error correction model, and then you put one restriction there, there is the co-integration. So there are a couple of like different models. So most of the cases in econometrics, these two models are not really we see very often. Very often also it's not seeing model 5, either 3 or 4. But you can either click like 5, summarize all, so that actually will give all results together. So you see that showing there is no co-integration relationship, like model 5 here. There are two different tests. It's called the trace and maximum eigenvalue test, right? But like, for example, here, if we use this one, we don't see here any co-integration relationship, right? And then again, so we change that, the value, now giving the maximum 12 lakh, and then we find. So you see that how sensitive, though you different test in the bar actually was giving, but when we estimate the co-integration relationship and then restricted bar, the optimum lag value is actually changing. So if we use the 2 lag value, it shows there is no co-integration relationship, meaning that long run relationship, but there should have like short run relationship. So, but if we use the 12, why 12 is because this is the monthly data. So it's in like 12 months in a year. So we use, and we see that it's rejection, none, and then accepted at most 1. I mean, because in our case, like we use the true variable, we can't have more than 1 R or the co-integration relationship. So it's accepted, you see that, but there is no co-integration relationship. It's rejected, meaning that there is co-integration relationship. And then there's two different tests. This is called the trace test, and then this is the maximum eigenvalue test, right? And then again, like 4, if we do this one and then use like 12 black, it's showing a different thing. So it meaning that maybe this model, I mean the model or the equation number 4 is more appropriate for estimating the co-integration relationship. So this is simply the test result, right? So in the second step I said, or just in the Anjar cases, like if the residual value does not have any unit root, meaning that these two variables are co-integrated. That's just when we use the simple OLS, considering PD as endogenous, or just we normalize either PD or PW. But here we consider together, they are endogenous together. So estimating the simultaneous equation. So this is simply the test. And then just to move to BER, I'm not going here. And then we estimate the vector error correction model. So we assured that these two variables are conjugated. And then this is the bar equation. Yes, sorry, yeah, bar. And then we move to the vector error correction, because we already know that there is a co-integration relationship. So we can't use the bar, unrestricted bar, but we should, or we must use the restricted bar. That's the vector error correction. So this is the vector error correction, meaning this is also bar but restricted. Restriction in the sense that there is one co-integration relationship. So here, for example, we use 12 blacks. We don't use any exogenous here. And then we use this model, right? Okay, I didn't put that. ED and PW. Are you listening me?
Yes, Prof. Yes.
Okay. So it's taking too much time. Okay. I don't know that how long I can go.
No problem, Prof. You just proceed.
So you see that this is the actual equation, right? I'll just show the representation. So you just see that how it's written there. So this is the co-integration, I mean the long run relationship equation, and this is the short run equations here. And this is the error correction. This is the error correction or the speed of adjustment term. And you see there's two variables. We use there's two variables as endogenous and run simultaneously in this equation. And then we see that when we use the domestic price as dependent one, in that equation, we see that error correction term, you can recall that I was saying that must be negative, less than 0. So you see that this is less than 0 and it's significant. This is less than 0, but not significant. So from here, we can somewhere like understand that without further testing, most probably that the PW is exogenous here, not endogenous. Only the endogenous is PD, meaning that in the long run, PD is not actually influencing PW, but it's the other way around. So if we say there's the representation, for example, this is that, right? So this is actually the equation we estimated, and this is the with the estimated coefficient. So this is bar model, but restricted bar. So you can see that here, this one, A1, this is the speed of adjustment, and then this is also a speed of adjustment. So you have say that this is the speed of adjustment. In this equation was like in the other window, you have seen that they are significant. This was significant, but it's not. It was not significant. And then, so you already know this one. Now, okay, just this one, and then estimate. Okay, no. Make a system just by this one. Okay. So this is for the exogeneity testing I'm doing. So it's already like the unit to test done, then the co-integration done, and then we assume that which variable is actually the endogenous and exogenous at this stage at least. So it's PD based on the speed of adjustment, which is less than 1, less than 0, sorry, and then significant. But in the wall price equation, it was not, it was less than 0, but was not significant. So this is that equation, you see. So I copy and paste this one. Sorry, I had to do that one. Not sure because, yes, it's done. So you see that one. Now you can test again, like putting some restrictions, for example, like C1 is equal to 0 or not, based on coefficient restriction. That's the wall test here. And then you can put like individual this value CJ, C10 or C1, for example, like C1 is equal to 0. So this is in the system case, but it's possible in the output skin window that's I shown in the vector allocation model. I'm going there. So you see that one. So you can't reject that one. I mean, the C is significant. That's already found. So C1 value is not 0, right? So you can do the all tests in that way. I'm taking much time without doing the main results. Just I'm going to.
Sorry to interrupt you, as we have another session. So how long it might take for you to complete the session? 15 minutes is okay, or you need more than that?
Okay, 10 minutes. I take 10 minutes. So I'm not okay. Just I stop here using the EViews. Now I move to WinRes, right?
Okay, sorry.
So this EViews actually I use in addition. This process also possible to use in WinRes, but I thought it might be very useful to show in EViews in case you don't have access to the WinRes software. But the other steps I can't do in EViews as because there's actually writing course of doing different tests that I presented using PowerPoint. Okay, just allow a couple of seconds. Just I'm switching my software and then also screen. So do you see my screen?
Yes, Prof, we can see your screen.
Okay. So I'm using this one, not this one. That will actually take less time. The full sample. Okay. So it's already written here. So it's not possible, in fact, to write all the codes in front of like during this time. So just I'm using my original code here, but I'll explain. So this is something like mapping the data. So in my case, like it's the complete data set. So where the data set is located. So this is something like you just saying software that data is there. So it's mapping. Calendar data starts from 1996, January 1996, and then is the data program is written already there in different programs. So here it's in the text tab, tab delineated text, and then it's in the column and so on. So it's the data matrix, and then starting from January 1996. So you see the calendar, and then it's ending December 2020. And then this is the domestic price, this is the world price, this is the exchange rate, and this is the rainfall in Brazil, domestic. So just this is the windows. So here, if there is any like previous output saved here, so you can just clear the memory clicking on here. YOLO. So it's all memory gone. So now you are saying that please find the data, execute instruction, and
Prof,
then
sorry, we cannot see your software screen, just only the desktop or the folder screen.
oh sorry, I'm just trying again. You see now?
Yes, now we can see the software.
You can see the software win rates. You see
Yes.
win rates. So what I said, the clear memory, if there is any already like output saved here, so I'm just clearing all memories here. So it's done. And then it's mapping the data set where it is. So what I said, the PW, PD, sorry, P, domestic price, the oil price, exchange rate, and rainfall. So here I clicked and then saying that, okay, you identify there, you get the data from here. So it's the orange data updated. So this is that text file, and it's already uploaded the data. So it's in the memory, right? So how do you check that one? You click here, and then you see the data set here. So PD, PW, the exchange rate, and rainfall data. Here, you just can see. So this is starting from 1996, and then it goes up to like, sorry, I'm trying to go quick. This, you see that December 2020, right? And then you can do all of like the kind of basic statistics, I mean all this descriptive statistics, or even like you can do the line graph here, bar diagram here, whatever you want. But I did that in Windows, and also the views. Also you can do the unit to test. For example, you see that here, the different test. Okay. So its data is there. So you see that we found these two variables, that the PD, PW, they are the IO1. So what I create new variables, that's the difference. PD, the difference one, the first difference, the domestic price, world price, and the exchange rate, right? So you just execute this command, it's done, already there. So you can see this series here, that These are the values, right? And then again, you can check if you want. So you see that there are 3 more variables, 3 more columns there, DIPD, DIPW, DI brass, right? And then, okay, we start testing the MTAR and TAR and MTAR. So first of all, just I do run the OLS, simple OLS. You see that the PD is the endogenous, and then constant, and the PW, they are the exogenous, they are the right hand side variable. So I run this model. You see that. So this is the very simple equation. So this is starting, and then you are saving the residuals from this estimated simple OLS of 2 different variables, oil price. And then again, you are just selecting that how many optimal leg using this course. But language I cannot explain here how to write this language, but I'm just clicking on that is because like I don't have time, I'm rushing out of time. So that is one program is called the leg breaks. So it's a separate program I already in my computer, and then I just use that one. So you see that I was explaining that the KENMS information criteria, and then the BS information criteria, and the Lujang box for serial correlation of that residual value, and then LM test, etc. And then 5 different simple journal to simple leg specifications. So this is all actually the different criteria showing different numbers. But you see AIC and then BIC, SBC 3, 6 different, but 6 is common in 3 different cases, AIC, Lujang box, journal to specific. But when you use the model selection criteria like AIC, BIC, or the Lujang box, LM test, or the journal to simple, they have different own merits and demerits. So if I normally go with this, the BIC value, and in this case, in my model, like I use the leg is 0 in the autoregression, right, of residual. And then now I'm just creating new variables. So you see that this is the residual one. So this is the leg 1, and then I define leg 1 residual. So mu t of leg 1, I mean mu t minus 1, mu t minus 2. That was in the equation of my PowerPoint, right? So I use these new variables. It's there already in the series. You see that all of this leg 1 to leg 12, leg 1 to leg 12, right? And then you define new, because I at some point I said that it's not the level value but the absolute one. So it's the absolute value, ABS, absolute value of the earlier leg 1. So it's the new definition. So I use this value, but this is the absolute value I'm using, and then setting new name, that's the absolute leg 1 residual. So is the mu t minus 1, mu t minus 2, but the absolute one. You can recall the PowerPoint that I used that. Okay. So that's also already created there. You see that different, like absolute below 1 to 12. Mohibullah, how long I can go? I'm rushing.
Actually, we had another session from 4. So if you can finish it earlier, it's better. The presenter is waiting.
Okay, just in 5 minutes. It's possible, but I give some impression that how it's done. So it's as because we identified that leg is 0 based on the BIC. So you see that on the TAR specification, I said that TAR and then MTAR, and then we decided we are going to momentum AutoRegressive model. So we didn't use any of leg here, just only the constant. So we run this one. And then this is based on the maximum F start value, and we don't see any of the F start value is significant here in this leg. So it's clearly we can decide that MTAR is not TAR is not appropriate here. So we move to the next MTAR, and for MTAR is not only the absolute value of the leg of residual, but the first difference of absolute value of leg of residual. So that's why just we create that again. You see that absolute value of leg 1 of the first difference of residuals. So you could recall my equation from the PowerPoint. So I create new variable, it's already done there. So you see this, you see that new variables is coming. So many variables. So you see, just I started with 2 different columns, but you know, it's now many columns. So it's like what we say sometimes is data generating process in time series, right? Okay. And then create this one. These are there in the memory. So all of the data matrix in the memory. So now I said that we use at some point, I mentioned that Hansen test, right? Just to identify the threshold. So here we found that in the MTAR is lag 1. So here in this case, now it's in the Hansen is lag 1. So you see that we found that maximum F test is value is 6.28, and then bootstrap P value is 0.02, meaning that this is the value, and then MTAR F start, and then we use the Hansen just to, as because we said that we can't use the conventional test, so we use the bootstrapping, and then using bootstrapping we found that at this point they are significant. So we use the MTAR model, and then we get confirmed that this model actually follows the non-linearity, not linear process is actually rejected. So it follows the non-linearity. So you see the hypothesis, test of null of no threshold against alternative of threshold under maintained assumption of homozygous error. That's in the equation. So test of null of no threshold is rejected, meaning that there is a threshold in the equation, right? And then, okay, we run the MTAR model. And then why we run this MTAR model? To identify the D value. You could recall that the D value, the delay value. So here we see that delay value should be like somewhere. 1, 2, 3, 4, 5, 6, 7, 8. Here you see this one, the F stat, and it's significant. I can't understand that whether you could follow this because there's so many equations, so many numbers. And then just for estimating the threshold, we know that there is a threshold effect, but we don't know the threshold value. And that's why just now we move to identify the threshold value using the grid search approach of Chan 1993. So this is something like when we use absolute value, calculate threshold value. So you see that in this code, how did I move that one? For example, like number of observation 85 and 15. I mean the lowest 15% observation eliminated and highest 15% eliminated. So it's just this threshold value identification. Chan model is actually will find a threshold value from the 70% of observation in the middle, not in the pool like the lowest 15 or the highest 15. And then you see that in the equation is because we found that delay is 6. So we use here the D6 just in the codes, D6 in the codes, but for other things it's like just writing something, the error correction time, defining different, this is the code language. So I'm not going to explain all this, but you see that how threshold value is identified. So you see that now I said that sum of square error is the minimum level. So here, this is the minimum one, right? Here is the minimum one, like 0.08, and you see the text written is threshold is 0.07537. And then we estimate now the TAR model with constant, and then we decide whether it's TAR or the TAR model or the MTAR model. And then again, based on this one, like you see, this one actually the error correction term was split into two different terms, and we see that they are significant and they are less than 0. So value of this one B plus, that's actually the error correction term I split into two different regions. So it's that this coefficient is less than 0, this coefficient is less than 0, and they are both are significant. And based on this, the assumption, you can test the null hypothesis. For example, they are 0. This one in and out, they are equal to 0, but it's rejected, meaning that there is co-integration relationship still. So we can say that error correction term is equal to 0. And then this is the test for the whether they are symmetric or not. So again, you see that in this case, it's showing symmetric, as it is not the original, I mean the paper data, but if there is a kind of like asymmetric behavior, it will be in fact significant one. So it's insignificant, meaning that until this point it's symmetric. So just in 1 or 2 minutes, I'm going to finish. So, but for the model rigorous understanding, that we again use the same thing or the same process in the case of like the wall price. So I run only for the domestic price, but now again the same equations we run for the domestic prices. So we do all of this test, and then for the threshold asymmetric error correction model, so we create new variables like the for example the exchange rate, as because we also know that there's also integrated one, and then run this model. For example, this is okay, something question problem. Okay, this is not the original one, that's possible, but you run this one linear regression simple OLS, or just if you want to run a sure model, for example, instruction is written, these two equation, this is for the domestic price and this is for the world price, and then you get the OLS or the sure model, and then based on this one, just you are testing, you put this restriction is equal to 0, for example, like 2 or 3, like this one and this one, to coefficient these two, they are equal to 0. So you write this, the variable number, and then put the restriction and it's equal to 0, and then you get the results. And based on that estimated model, either you use the sure or OLS, or use the asymmetric or the symmetric. For the model selection criteria, as I said, that you can use the AIC or BIC, and also just test for the model diagnostics, for example, autocorrelation, stability or normality, and so on. So I stop here. I'm sorry, it is taking time. In fact, it's because explaining so many things, Mohidul, and then others. If there are any questions from participants, maybe just they can follow up with me. They can send email, I can respond, as because I don't want to take any time now, as because the other speaker is waiting. Sorry for that. Thank you for hearing, but I'm sorry if it really very complex one, but the topic was.
Really, it's a pleasure to have you in this session. Actually, many participants are eagerly waiting for your session. So if we could give you more time, then it should be nice. But as we already got the situation in the morning for the technical issues, you cannot start the session. And we actually organized this way so that we don't need to just shorten the time. So as in the afternoon session, we scheduled 2 sessions. We know that these 2 sessions will complete in 3 hours, but your session, we expected more time. So it's really our bad luck for the technical issue. So inshallah, as you mentioned that if we need to know anything else, so we can contact with you. We'll share your email contact information to the participants, so that if they need anything, maybe they can contact with you later on. So is there